Good day and welcome to our webinar presentation on flying the Garmin GFC 600 Autopilot. On behalf of Sporties and Garmin Aviation, my name's Eric Radke and I'm the Chief Instructor at Sporties and also serving as your facilitator for the day. A big thank you to Sporties Pilot Shop for sponsoring the free webinar series from Sporties, and we appreciate you thinking of Sporties.com for all of your pilot needs. And also a big thank you to Garmin Aviation Training for joining us today and providing all this great content on the GFC 600 Autopilot. And when you're thinking about your next investment in avionics, be it portable or installed, thanks for thinking of Garmin. We hope it's not your first time on a webinar presentation, but just in case, we do want to point out that the entire presentation will be recorded and it will be available in the Sporties webinar archive. So if you miss something or want to come back and review or have to step away, you'll be able to come back and see that presentation as frequently and as often as you would like. And I would also like to invite you to submit any questions that come up throughout the presentation via the GoToWebinar software. And with some help from the Garmin Aviation team, we will be responding to those questions in the background. With that, it is my pleasure to welcome from Garmin Aviation Training, Mr. Matt Clark, our presenter for today. Matt, welcome.
Well, thanks, Eric. It's an absolute pleasure to be presenting with you guys again. As you said, on behalf of Sporties, on behalf of Garmin and Garmin Aviation, it's definitely glad to be with you guys today. For those that don't know me or haven't seen some of our webinars in the past, my name, as Eric said, my name is Matt Clark. I'm a senior aviation pilot trainer here with Garmin International. Garmin-wise, I've been with the company about 7 years. First couple of years with our aviation product support team. They are the ones on the phones, answering the emails. Learned a good amount of Garmin equipment in that very, very quickly. Outside of that, I've been with the remainder of time with Garmin has been with the aviation training team themselves. And we teach everything from GTNs or flight displays such as TXI, G3X, our autopilots like we're talking about today, as well as our integrated flight decks such as G1000, G3, 5000, and other topics as well. Outside of this, I am an active CFII. I teach in the local Kansas City area for one of our local flight schools, as well as some local flying clubs. I'm a commercial single multi-engine rated pilot, and definitely been fortunate enough to fly behind this equipment, this autopilot, and have a good understanding of what it's going to do, how it's going to work, how we're going to be able to use it and operate it within the airspace. Well, with that said, we do have a lot of great content. As we said, we are talking about the GFC 600 AFCS, or Automatic Flight Control System. Definitely a lot of good stuff we're going to go talk about today, so let's jump on in here. As with all of our presentations, just kind of our standard legal disclaimer here, we're not here to necessarily teach you how to fly your aircraft. We're also not here to replace any of the publications that are going to come with the system, including pilot's guides, flight manual supplements, service bulletins, service alerts. Those are all going to still take priority, but we're here to complement those resources and more or less put the pilot spin on this and how we're going to operate this equipment to get the most out of it. So basic contents for today, we're going to start off, we have a couple autopilot basics we'll kind of briefly touch on. Then we're going to get into some system components, layouts, what equipment is going to make up the GFC 600. We're then going to do a dive into our AFCS statuses and enunciations. We always want to have a good understanding of what the autopilot's doing, what's active, what's armed. So where can we tell some of these different statuses? We're going to then jump into a good in-depth discussion on the mode selections and the individual modes that are available with the GFC 600. We'll talk about some of our electronic instability and protection, some features that are built into every single GFC 600 that we sell. We will cover a few abnormal operations. I'm not going to cover every single abnormal op you may run into, but we'll cover some of the big ones that you could potentially see. We are then going to go into some of the autonomy features. Now, it's been a couple of years since I've done this presentation with Sporties. There's been a lot of changes that our engineering team have done to add features, improve the autopilot, and some of those features are great tools that may be available on your aircraft. And then we're going to end the scenario, or end today, with a flight scenario of starting the aircraft on the ground through departure, en route, descent, into the approach, and even into the missed approach of how we can run the autopilot and really get a good sense of how to use the equipment. Now, as Eric said, we do have a couple of colleagues with us today that are standing by ready to answer any questions that you may have as we're going through this presentation. If you do have that question, please use that question box within the GoToWebinar platform. We'll be more than glad to answer those questions. If you do have a question that either does not get answered today or you have down the road, feel free to email us here at aviationtraining.webinar@garmin.com. I will say the one caveat, we're not necessarily going to answer if your aircraft is on the AML or if what's planned. I do have a slide at the end of where you can go find that information, but I'm not necessarily going to cover what's currently covered under that during this presentation today. So with that said, let's go ahead and let's just jump right in. We're going to start off with a couple autopilot basics, some fundamental stuff that we want to think about running Garmin Autopilot and some just autopilot in general. Now, there's 4 basic rules to autopilots, and these are actually Airbus's golden rules to automation. Now, they're focusing it on obviously their aircraft, but the same principles are going to apply to general aviation as well. So the basic 4 rules that we want to follow at all times. First off, aviate, navigate, communicate. We've all heard the adage, we need to fly the aircraft. That's the primary, whether it's automation or whether it's hand flying. We have to be in command of the airframe. Next, we need to make sure we're navigating. Whether you're heading mode, whether you're following GPS or a VOR course, we can work the navigation side. And then the very end, then we can communicate with ATC as appropriate. Next up is the use of proper level of automation at all times. There's several different resources out there that describe different levels, but the most extreme case, you could be coupled up on an autopilot laterally and vertically. You could have it following that approach guidance all the way down. You could be running the missed approach. If you need to, if things aren't going quite the way you want, you may need to come down a level, fly into, say, a heading mode, an altitude hold mode until you can figure out what's going on with the automation. And even worst case there, you can disconnect the autopilot and hand fly. Even that can be a proper or an appropriate level of automation. Number 3 is a big critical one, is understanding the FMA or the flight mode enunciator. That's what a lot of different panels call the autopilot scoreboard there. Our system, we call it the AFCS status, the automatic flight control status. With the GFC 600, you'll see it on the mode controller, as well as potentially some of the flight displays that we have. We're going to talk about that later. But always understand what the FMA or what that AFCS status is telling you, because if you ever ask the question of where's the autopilot taking me, well, we didn't understand what the autopilot enunciations are. So we need to go back, look at it, see what's active, see what's armed. And the very last one is if things don't go as expected, take action. Do something about it. If the autopilot is not taking you where you think it should be taking you, if it's not doing what you think it should be, disconnect the autopilot and hand fly the aircraft. Some other items to kind of look at, and more or less how I run most Garmin autopilots here, is more or less a 4-step process. Starting off with setting a reference. So if you're going to follow a heading, start by setting your heading book. If you're going to climb or descend to an altitude, set your altitude in your altitude selector. If you're going to follow a nav guidance, nav course, set your course, whether that's on green needles, tracking a ground-based nav source, or whether that's following GPS guidance. Set your reference first. After that, we're then going to select the mode. So going into a nav mode, a heading mode, vertical speed for descent, indicated airspeed for climbs, whatever mode that you may need. Step 3 at that point would then be to set a rate if appropriate. Really mostly applies to vertical speed and indicated airspeed. So set your mode, set your reference, set your mode, set the rate, how fast up or down do you want to go, and then of course, verify. Anytime you make a change that's going to interact or affect the autopilot, verify the AFCS status, make sure you know where the autopilot's going to take you. So there's kind of a quick couple autopilot basics, and now we're going to jump into some system components and layout. What makes up the GFC 600? What's commanding the aircraft when the autopilot's on? So first and foremost, what we're going to interact with the most is the GMC 605 mode controller. This is what we're going to interface with. This is what we use to turn the autopilot on and off. We make our mode selections, we set rates. We can even see on the screen, there's different enunciations that you'll be able to see and reference. This is the front face of what you'll see. This box does have an integrated AHRS, or attitude and heading reference system. So unlike some other systems, we're not having to pull that attitude data from any other place within the aircraft. It's all going to be self-contained within GMC 605 itself. And of course, this is going to integrate with a number of both third-party and Garmin displays and nav sources. Next major component as part of the GFC 600 is the GSA 87 Smart Servo. This is what you're going to find. This is the primary servo for most GFC 600 installations. They all have onboard microprocessors. They're capable of their own electronic torque and speed sensing. So it can be very dynamic on how much torque or how much input it needs to throw onto the controls. It's very, very smooth to fly behind. They're really phenomenal pieces of equipment. They are a brushless motor design, and they have no mechanical slip clutch. Really means on the owner operator side, it's going to be improved reliability in the long term and ultimately lower maintenance costs overall, which are always good factors there. Some installations, there are a few out there that do use the GSA 80, GSA 81 servos and the GSA 86 servo mount. The great example on that would be the Citation 525. Most installations use the GSA 86, but some will use that. These are very much time-tested and proven servos. In fact, these are the same servos that are currently found in a lot of G1000 and G1000 NXI platforms. So they've definitely gone through the ringer a few times before coming to the retrofit side. In addition to that, on select aircraft, once again, the great example is Citation 525, the GTA 82 trim adapter may be interfaced in, and this is ultimately going to control third-party trim actuators. That's very specific on which airframes are going to use those two options, but you may see that depending on the install. Now the GI-285 mode enunciator, this may be an optional piece of equipment. It could be in the primary, or normally it's going to be placed within the pilot's primary field of view. This is if you have, especially with the GMC 605, it could be at the bottom of the stack, top of an instrument stack. It's going to be outside of a certain field of view. This is where this would be required. So it's going to display all your active, all your armed autopilot modes. And it's going to follow the same logic that Garmin has used for all of its other autopilots, showing green for active modes, white for armed modes. Very similar, if not identical, footprint to other mode enunciators that are already out there. They're all lit up via LED backlights for real long-term reliability. From a layout perspective, you could start off from something fairly simple, and this, once again, it's going to depend on the aircraft, depend on the installation, but at very minimum, you're going to have a roll and a pitch servo. You're going to have the GMC 605. You could have something along the lines of what we see here of just a standalone nav radio with a standard basic CDI. In this particular case, more than likely you would need the GI-270 or GI-285 mode enunciator, that guy right up there. Adding a third servo is going to allow for pitch trim. So we can automatically pitch the trim as appropriate when the autopilot's on, so automatic pitch trim, as well as adding in the capability of a manual electric trim. Fourth servo is for the yaw damper, so minimizing some of those yaw oscillations and helping to maintain some of that coordinated flight. Of course, our GFC 600 does integrate into a number of different GPS and VHF navigators. Here we can see the GTN or GTN XI series of navigators will integrate rather well. Same with the GNS WASP series, GNS WASP 430, GNS 530, either one there. Also integrates with a number of different displays. Running the Garmin side, if you interface with a TXI flight display or a G500, G600, then you'll see additional enunciations on there. When you have one of those displays, notice how you no longer need that GI285 mode enunciator. Reasoning is those enunciations are now on your primary flight display and are very much in your primary field of view. So the other piece of equipment becomes optional and really is not needed in that particular installation. So, but this is just one particular layout. I definitely recommend talking with your Garmin dealer about more specifics on your aircraft, what equipment you want, and go from there. Some enunciation-wise, where do we find some of these different enunciations? Because we're constantly, you've heard me say at least once already, we want to verify. Anytime we make a change, we want to verify one of the enunciations. Well, you're going to see them in a number of different places. I'm going to start off first with the GFC 605 itself. Now, the 605 is arranged fairly logically here. On the left-hand side, you're going to see your mode engagement section. This is where we can turn the autopilot on, turn your flight director on, turn the yaw damper on, and they are color-coded. There is a color-coded light next to each one. When we get into the abnormal side, we'll talk about some of the different colors that you may see there. In the very center of the display is an LCD display, and this is going to tell you your lateral, your vertical, as well as any system messages that are being generated. On the left-hand side, you're going to see, right below my laser pointer, you're going to see your lateral mode selection. Everything on top is your active mode. So in this case, we're in a roll mode, but we have on the bottom GPS mode or nav mode armed. In the center is your vertical, same thing. Top row is active, your bottom row is armed. And then of course on the right is any system messages that the GFC 600 may be generating. In this case here, we may be an out of trim indication. If you're flying a multi-engine aircraft with smart rudder bias, it could show that that's active. If you have any sort of fail alerts, that's where you'll see them as well. Of course, we did say if you're running a Garmin primary flight display, such as a G500, G600, or TXI flight display, you will see the enunciations at the top of your PFD. That makes life very, very simple, and it's going to self-simplify your scan. On the left-hand side, or I will say before I go to there, we do follow the same logic we followed on other panels. So if you're used to flying G1000 now, you're going to see that AFCS status in the same spot and in the same layout. So we've kept that, try to keep that as simple as we can. On the left-hand side is always going to be your lateral mode selection. In the center is your autopilot status. So here you can see on both the autopilot and yaw damper are turned on. And on the right side is going to be your vertical mode. You can see both of those. You have vertical speeds active with an ALTS or altitude target select armed. So some great ways that we can verify all of our statuses there. Now, following standard Garmin logic here, green is active. If you see a green enunciation on your primary flight display up at the top, that is what the autopilot is doing right now. Your white is your armed mode. Armed meaning we are waiting to get there, whether it's you're waiting to intercept a course or you're waiting to capture an altitude. White is armed. Yellow you will see pretty much every time you run the autopilot. That means it's either a mode drop, so if you manually change a CDI source, you go from GPS over to that localizer or over to a VOR, you will see the lateral mode start flashing yellow. Same thing if when you disconnect your autopilot, you hit the AP disconnect on your yoke or you hit the AP disconnect on the mode controller itself, AP will flash telling you that you are now in command of the aircraft and the servos are no longer flying the aircraft. Red, anything in red on there, is an abnormal disconnect. Something in the system has caused the autopilot to disconnect, in which case you'll get a lot of oral tones, and we're going to verify, and we're definitely going to make sure that you are hand flying the aircraft at that point. Always reiterate at this point, always verify what your active and your armed modes are. Question I get quite a bit from pilots from time to time is, hey, why did the autopilot do X, Y, and Z? My first question to you is going to be, well, what did you see up in your AFCS status? What did you see at the top of your primary flight display? What was the active, what was the armed modes? A lot of times I get the answer back of, well, I don't necessarily know, or I didn't look at it, I didn't pay attention to it. And we go back to some of our golden rules of automation there. We always want to understand, we want to verify, we want to know 100% sure what the autopilot's doing at all times. All right, so now let's take a look into some of our mode selections. We're going to take a look at both all the lateral, all the vertical modes, how we can interact with them. If we do have some questions there, there's some great examples that we'll have during our flight scenario at the end of this. So first off, let's take a look at our autopilot engagement selections. Now you do see we have an autopilot button, a flight director, and yaw damper. Now the yaw damper and flight director can be turned on independently of the autopilot. So a great example, some of the aircraft I fly, moment you get the gear up, flaps up, we'll turn the yaw damper on, start letting the yaw damper aid us on our climb out. A lot of times I'll have the flight director running while I'm still on the ground, so I have some reference to climb out at. And then once I'm above the minimum altitude and airspeed, I can turn the autopilot on. So I could turn all three on independently of each other. Now selecting the autopilot does automatically turn on the flight director and yaw damper. So pressing the top button engages the others, but not the other way around. Now for those that are flying with a TXI flight display, if you turn the flight director on, but you don't have the autopilot on, you will see a hollow command bars, your hollow flight director, what you're seeing on the screen here. We can also verify that against the GMC 605, where the green light is not lit up on the autopilot. So we are still hand flying the aircraft. And we'd also look at the AFCS status on top of the PFD, and we'd show that the autopilot's not engaged. So you have some cross-check already built in within the system. Versus when you turn the autopilot on, the flight director command bars will fill in. So you may see some variation on that on some of the displays, but with TXI, it's a great additional tool to cross-check. Now, one button that is not part of the GMC 605 is a go-around button. This can be mounted in a number of different cases. I've seen them with a button on the throttle. I've seen them mounted to the dash, just a standalone button. Regardless of where it's mounted, it's all going to do the same thing. This is a combined lateral and vertical mode. What it's going to do is set your flight director automatically to a go-around pitch attitude. This is typically about 7 degrees, but will vary based on the aircraft you're flying and whatnot from there. It's a great tool if you're taking off. You can select go around and have a pitch reference to climb out at. It also works really well for the coupled go around. If we need to go missed approach on an instrument approach procedure, we can hit go around. In this case, the autopilot would still stay engaged and start carrying on through the missed approach procedure. We'll talk about that a little bit more in our flight scenario. On your lateral mode selections, you do have a number of different options there. The first, where it's not necessarily a button, but is roll mode. So if you were to take off, you hadn't turned a flight director on, you haven't touched the autopilot, if you turn the autopilot on, or flight director for that matter, the default mode is roll. In a sense, it's keeping the wings level. It's a very, very basic mode. It's not correcting for wind, it's not following a heading. Typically, if you see yourself in a roll mode, we want to go back into something better, such as a heading, a nav mode, something along those lines. It's also the mode if you were to select a mode that's already active. So for example, if you were in a heading mode already and you hit the heading button a second time, then it would revert to a roll mode. Next is the heading mode itself. It's going to acquire and maintain your selected heading bug. That's one reason I always say set your heading bug first, set the reference first. If you don't, as we're turning, we've been navigating, your bug, that heading reference may not be right where you want it. You could get an uncommanded turn before you're able to readjust the heading bug. So always recommendation, set the heading bug first before we go into heading mode. Nav mode is going to acquire and track your selected nav source. So for example, if you're already on GPS, that's what you've got selected on your CDI, you're following GPS course guidance. When you press nav, you're going to see a GPS enunciation. Same thing for VOR and localizer. If you're on green needles, you're tracking a VOR on your CDI and you select nav, well, it's going to track that VOR and so on and so forth. Back course is what you're going to use if you're getting ready to go fly a say a localizer back course approach, or you're wanting to track a back course off a nav aid. Dial in the nav aid, make sure you've got the right course set in, right CDI source, select back course, and then that's what you'll fly off there. Some installations, not all, will use a low bank mode or have a low bank mode. This is really used for high altitude operations, where if you were to fly a standard rate turn, would put a lot of extra forces on everybody on board the aircraft, including your passengers. And so what we can do is we can limit the maximum bank angle. And you'll see that when you go into low bank mode on your primary flight display, you'll see that green bar. That is showing where the roll limit is now set to. Now this can be either done automatically above reaching a specified altitude, or it can be done manually with the low bank button that would be mounted elsewhere on your panel. Approach mode is one we'll definitely use quite a bit, especially working within any sort of instrument approach procedure. This is more or less a combined lateral and vertical mode. It's going to arm the lateral mode as appropriate. So if you're on a heading like we are in this case, you're on a heading to intercept that final approach course, your heading's active, we can arm approach mode, and you see LOC and GS in white, or GPS and GP in white, depending on what we're flying that day. And those modes, once we intercept that final approach course, and once we intercept that vertical guidance, they would then become active modes. Now we do say it arms the lateral mode as appropriate if you're flying under GPS guidance, going to an initial approach fix, and you're getting ready to fly a GPS approach. Well, there's on the lateral side of things, there's nothing to arm. You're going to follow GPS all the way through. So in that case, the only enunciation we get would be a white GP for glide path. We do have a great example in the flight scenario here shortly. Vertical modes, same sort of deal there, with first being pitch. There's no reference specifically for pitch. It is the first mode. If you were to just turn the autopilot on or just turn the flight director on without selecting any other mode first, you would see it as pitch. Going to maintain whatever the current aircraft pitch is. You can use the up and down wheel that you're seeing on the right-hand side of the unit to adjust the pitch angle, but typically I try to get out of pitch fairly quickly. I don't like flying with that mode as the active mode. The up and down wheel itself is a multifunction wheel. It's going to be used to control our indicated airspeed, our vertical speed rate, as well as the pitch rate. So that's one we will use on a regular basis. The other button there we'll start off with is the altitude button, ALT. Now the altitude button, all it's going to do is capture your current altitude that you're at. It's not a button I actually press very often when I'm flying, because I'm usually going to use my flight display and pre-select an altitude initially. But if we're hand flying and I need to level off wherever I'm at, pressing the altitude button will set that reference. You can adjust the altitude with the up and down wheel, plus or minus 200 feet. So a great example is if you're at 3,000 feet, the approach you're getting ready to fly has an altitude of 2,900 and you want to come down. Instead of using the altitude selector, going to vertical speed, setting a descent rate just to come down 100 feet, you could just scroll that wheel down and you're going to see the altitude reference on your AFCS status change, and then the aircraft will take you down. So it's a very quick way to make minor altitude corrections. Other vertical modes, the ones you'll use quite a bit, are the indicated airspeed mode, when you press, and vertical speed. Both operate very similar to one another. When you press either one of those modes, it's going to capture what you're currently doing right now. So if you're on your climb out and you select IAS, it is going to capture whatever indicated airspeed you are currently flying at. You can then use the up and down wheel to fine tune that airspeed to whatever speed you want to climb out at. Vertical speed does the exact same thing. When you start climbing or descending, when you select vertical speed, especially if you're in level flight, it's probably going to default to 0 because you're doing in level flight 0 vertical speed. You can then set that rate of descent using that wheel and watch it change on your AFCS status, or watch it change on the GMC 605. VNAV is going to allow for programmed descents, and this is the enhanced descent feature that's going to be found within the GTN or GTN XI series. So you have to go through some steps with those units to make sure that you've created your descent profile in that unit. Then you can arm VNAV on the Autopilot on the GMC 605 here, and that will let you come on down following that calculated path. This does require GTN software 6.5 or higher, or GTN XI, one of those two. If you have more questions on VNAV, take a look at Garmin Aviation's YouTube site. We do have a good in-depth webinar talking specifically about VNAV. So that'd be a great reference for you there. The last button on there that we have not talked about is level mode. And that is a combined lateral and vertical mode as well. Simply pressing the level button will engage the autopilot if it's not already engaged. It's going to command 0 bank. It's going to command 0 vertical speed. It's going to put you into level flight. This is a great tool if you're hand flying the aircraft and you start encountering some spatial disorientation. Press the blue level button, get the aircraft back under control, and at that point we can then select whatever lateral and vertical mode we want and continue flying the aircraft. All right, so now we're going to take a quick look into our electronic stability and protection, or ESP. Now, ESP could be thought of as an envelope protection. We're trying to keep the aircraft in a safe and protected envelope. We can correct for bank, for pitch, as well as for airspeed. The further we get away from this protected envelope, in this case here on this picture, if you go further into the red sections, the more you're actually going to feel the autopilot servos start fighting against you. They're guiding you, they're nudging you back towards that safe protected envelope. On the roll side of things, we're going to try to discourage banking beyond 45 degrees of roll. And you can see on our display here, you're going to have 2 hash marks on the roll cage at 45. When you go past 45 degrees of bank, those double hash marks are going to come up to 30 degrees. So we're going to guide you back into that safe envelope. The further we go beyond that, the more the servos are going to fight against you, up until about 70, 75 degrees. Once you get beyond that limit, then ESP is going to turn off. So thing to remember with ESP, this is not upset recovery, but where this is more that flight envelope protection. So we're trying to prevent you from going into that unusual or extreme attitude by guiding you into that safe envelope. Same thing can happen for pitch. We're going to try to discourage from pitching up too high or pitching down too low. The pitch side, this will vary much more with each airframe. For example, the Cessna 208, the ESP limits are at 16.5 degrees up and down, whereas say an A36 is 21 degrees up, 25 degrees down. So check your aircraft flight manual supplement. It's going to have all the specifics on that one. Now, ESP itself can turn on level mode automatically. As long as you're above 200 feet AGL, if you go outside of that safe envelope for more than 10 seconds within a 20-second time frame, you're going to get an oral alert of engaging autopilot, and we will automatically place you into level mode. We make an assumption that something's not going right. So you're experiencing some sort of spatial disorientation. We're going to get your aircraft back to level flight. Now you can get around that ESP, those 3 ESP thresholds, and avoid this from happening, especially if you're getting ready for, say, like a commercial check ride, or you're trying to do steep turns beyond 45 degrees of bank. If you press and hold the autopilot disconnect, that'll turn off the servos. And if you hold that AP disconnect for roughly 5 to 6 seconds, then you will actually disable ESP, and you'll see an ESP off message on the 605. And it'll stay off until you re-engage the autopilot. So we do have the ability to turn ESP off if we need it. Now for the high speed and low speed protection, this is still while we're hand flying the aircraft. High speed protection, we're trying to prevent the aircraft from going too fast and exceeding VNE. Low speed protection, same sort of deal. We're trying to prevent that stall. We're trying to prevent you from going below a specified airspeed. Now the low speed protection is going to require either a GNS WAS or GTN or GTN-XI with a valid terrain database. The reason that is, we are also going to inhibit the low speed protection below 200 AGL. We have to have some reference back to that terrain database to be able to do this. Big part of this is we don't want ESP or that low speed protection to start lowering the nose while we're trying to work into a flare. It'd be a really bad time for that to happen. So we do automatically inhibit below 200 AGL. Now, the next two features are not specifically ESP, but they kind of lump into the same category here. We do have overspeed protection and underspeed. Overspeed and underspeed protection are going to work while the autopilot is on. Some hard set limits there. It's going to pitch the nose up to reduce exceeding VNE. You're going to get a max speed alert on your primary flight display as well as on the GMC 605. Your vertical mode is going to change to an indicated airspeed mode, something that's going to be slightly below VNE. Your previous mode, whatever mode you were tracking before, will change to armed until we reduce some speed on the aircraft. So reduce the throttles, reduce the power, slow the airframe down. The previous mode can then become active, resume you back into normal flight. Underspeed protection, very, very similar. We're trying to get you or discourage you from going below a certain airspeed. That speed is going to vary airframe to airframe. In this case, you'll get a min speed alert, and it's going to try to keep you above a knot or two above that minimum speed, but it's going to do that by pitching the nose down. Same deal as overspeed. It is going to change into an indicated airspeed mode. You're going to get that constant airspeed alert if you're in an altitude critical mode. And once your airspeed increases, then we can resume that previous mode we were in. All right, now we're going to cover a couple abnormal operations. Not going to go too crazy into this. I will encourage everyone to read through the aircraft flight manual supplement for your aircraft. It is going to have a lot more details and a lot more potential abnormal issues that you may run into or could potentially run into. Very highly encourage you to take a look there. So the first one you're going to see, one you'll see every time you operate the autopilot, is the yellow flashing AP. You'll also see a yellow AP flash on your primary flight display. And you'll get, when you disconnect the autopilot, you are going to get a standard disconnect tone. That means that you are now hand flying the aircraft. You'll notice after the AP light then goes away. Same thing on your PFD, the AP would go away. You may still have the flight director up depending on how you disabled or turned off the autopilot, but the big part is you are hand flying the aircraft at this point. You may also see a yellow flashing AP in the event of a trim fail or a mistrim condition. If there is that issue happening, look at the 605 and you're going to see some alerts. In this case here, elevator trim up. We need to trim up a little bit and get the aircraft back into proper trim. The servos are having to hold some of that nose pitch up. A flashing red AP means that you had an abnormal or an automatic disengagement of the autopilot. Something in the system has caused the autopilot to fail. You're going to get the same autopilot disconnect tone. The only difference is that tone is going to keep going on and keep sounding until you acknowledge it. You acknowledge that by either pressing the AP button on the 605 on the mode controller here, or by pressing the autopilot disconnect on your yoke. And of course, once you get that tone, you've acknowledged it, you'll see the AP fail message on the GMC 605. Something has caused the autopilot to fail. Don't try to re-engage the autopilot until you've either had a chance to do some troubleshooting, figure out what's going on, or better option, land as soon as practical and figure out and then do some troubleshooting on the ground. Another one that you may see fairly regularly is if a mode drop. We say that if you manually change your mode from, say, you're on GPS and you change to VLOC, you go start tracking a VOR or vice versa. When you manually change that CDI source, the mode will drop and the lateral mode will revert to a roll mode, which point we would need to re-engage nav or go into a heading mode. We can continue from there. Now, those are just a couple quick abnormal ops that you may see. Once again, double check, verify, read through the AFMS. You'll save yourself a lot of hassle in the long run there. Some newer features that have been added to this and may or may not be available on everybody's aircraft. It is going to vary and depend a little bit there. We have three big features under the Autonomy umbrella that we want to talk about. The first is smart rudder bias. We're then going to talk about emergency descent mode, and then we'll talk about smart glide. Now, all of these features do require another piece of equipment to be installed. For example, smart rudder bias requires TXI's engine indication system, or EIS. Emergency descent mode does require a TXI flight display. And for smart glide to work, it does require a GTN XI that's been configured properly. So it has all of our best glide speeds and glide ratio and whatnot. First one we're going to talk about is smart rudder bias. This is going to be available on select multi-engine aircraft, and it's really going to help and maintain some control or assist in controlling the aircraft during the event of an engine failure, during the restart process, or worst case, the securing process. And ultimately, this is going to try to address three main or major concerns while running single engine operations. First is a large yaw motion. We know that the inoperative engine is going to produce a large amount of drag until we can secure it. The loss or potential loss of lift, and the big critical one there for us is critical loss of airspeed. We don't want to get below minimum controllable airspeed. So smart rudder bias is going to do this a number of different ways for us, and it's going to do it pretty simultaneously and automatically. First is it's going to drive the rudder opposite direction of the failed engine. Notice how on your primary flight display, it's going to point out what engine is inoperative. In this case, the left engine is inoperative, so the rudder is kicking to the right. The servos are automatically driving it to the right. You're going to see a rudder bias alert enunciation on your PFD, as well as RB, or rudder bias active, on the GMC 605. Second is it's going to lower the ESP threshold in the direction of the failed engine. That's that green double hash mark. Those were the ESP roll marks that we saw originally at 45 degrees of bank. Here, with one engine failed, you're actually seeing it in this particular aircraft, it rolled it to 10 degrees. So if we do start banking to the left, or we're not paying attention, we're trying to secure the engine, if we let the aircraft slip a little bit too far to the left, the aircraft will then nudge it back into that safe envelope. So it's reducing that ESP threshold before the servos are going to engage. It's also going to lower the ESP threshold. On this aircraft, this was taken off a 58 Baron. Normally the pitch up is 21 degrees, pitch down to 25. With smart rudder bias active, the ESP pitch limits reduced to 10 degrees up and 5 degrees down. So we're going to try to help you maintain altitude as best as we can. And then of course the big one is we're going to put a low speed limit, the underspeed protection there, at 1 knot above VMC, one knot above red line. So we don't want you going below that, because now we're definitely in a very bad scenario. So these are all features that automatically turn on. Now these same things will apply regardless if the autopilot's on or if you're hand flying. In this case, we happen to be hand flying it, and you're seeing all this stuff appear on the PFD. Very useful feature there. Now, smart rudder bias, this is to be used during the initial phases of, you've detected the engine shutdown or something's happened, you're in the initial restart, or once you can get it secured. Once it's secured, if you do have to have the engine secured, we will go in and turn rudder bias off. At that point, you're now hand flying the aircraft with the inop engine. And the big limitation you'll read in the flight manual supplement is single engine landings with rudder bias on is prohibited. So big limitation there. Next up, for some aircraft, is emergency descent mode. This is going to aid the pilot in the event of aircraft depressurization. Not available on every airplane, but select aircraft it is. You can either engage it manually with an emergency descent mode switch that'll be mounted elsewhere on the panel, or if your TXI display is configured and to detect that cabin pressure, it can automatically kick in for you. With EDM or emergency descent mode active, it's automatically going to descend the aircraft down to 15,000 feet. We're trying to get down to where there's a little bit more oxygen and hopefully try to prevent you from succumbing to hypoxia. Big thing that this is going to do when EDM is active, it's going to set a heading bug 90 degrees to the left. It's going to automatically set 15,000 feet into our altitude selector, and it's going to descend at the maximum allowable airspeed. So heading on the autopilot and indicated airspeed mode are going to become the active modes. You're going to see that speed set to just below max speed or VMO, and it's going to start a fairly rapid descent. Now, when it detects that you've lost cabin depressure or lost cabin pressure, it is going to start a countdown timer. Now, you can inhibit that timer. If you, on your TXI display, if you hit there, press the inhibit EDM button, it will start a 5-minute countdown timer. After 5 minutes, this is give you enough time to try to troubleshoot, repressurize the aircraft. If the conditions still exist, if the aircraft's still depressurized, emergency descent mode will go ahead and kick on in. Last thing we want is you inhibit the emergency descent mode and then something happens and you succumb to hypoxia. So we're going to start the descent. Now you can override that at any point, and you can even deactivate emergency descent mode if you want by simply disconnecting the autopilot. AP disconnect on the yoke, the AP button on the mode controller, or same through the menu, test button, and then AP disconnect on the flight display itself. Any of those work just fine. Last feature within Autonomy we're going to talk about is Smart Glide. And there are some other resources out there that go into a little bit bigger detail on what Smart Glide is going to do. But in a sense, in the event of a total power failure or partial power failure, but in the case of a twin engine aircraft, if you have dual engine failure, this is when we would use Smart Glide. It's going to locate and pick out the best glide airport, and it's going to do it automatically for you. It's going to create a direct to that particular airport if it's within glide range. And if the airport's more than 2 miles away, it's going to automatically engage the autopilot. Great way to start navigating to that airport. It's going to set you up at your best glide speed and get you to the airfield. You can activate it by either pressing, if you have the installed Smart Glide switch on your panel, pressing that button, or if you don't have that button, you'd be pressing and holding the direct to button for 2 seconds. It's an either or. Now, if the airport is within range on the autopilot, it's going to go automatically into GPS and start tracking that GPS to that airport, and it's going to set the indicated airspeed to your best rate of descent or your best rate of descent. If the airport is out of range, out of glide range, then it's going to go into a roll mode. It's going to keep the wings level, but still the same thing. It's going to set your best glide speed and the indicated airspeed, and at very minimum, it's going to control your descent rate through there, allowing you to run through checklist and whatnot, depending on the altitude you're at. All right, the last little bit I've got for you, we're going to run a flight scenario. This is from takeoff through touchdown. First, we're going to be taking off from Memphis International, heading over to Fulton County Executive, just north of Atlanta. For the sake of this scenario, we're going to say we have a TXI flight display. We're running a GTN 750XI, and of course the GFC 600 Autopilot. Our profile today is pretty straightforward. We're departing out of Memphis International via the Elvis Ford departure, E-Tree transition, into Fulton County Executive. We're gonna arrive through the Sweetie to arrival, Lipton transition. Just a fairly straight shot over there. So on the ground, we get the clearance number 12 Gulf Romeo Mike. You're cleared to Fulton County as filed. Climb via. Expect 15,000. 10 minutes after departure. Contact departure 12415. Squawk 2153. We load all that up. We're going to assume we've got our flight plan already loaded. and we'll start working our way through, and then we'll call tower, we'll tell them, hey, tell us, hey, runway 9 cleared for takeoff. So this departure is going to be runway flight, runway heading, climb and maintain 3,000. That's essentially, if we look on the departure, the top altitude's 3,000. It tells us to fly runway heading and expected vectors to on course. So we're going to set that up. So first, we're going to set the heading bug on our primary flight display, and I can see I'm right now heading 093, heading bug set to 093. We're all happy with that. I'm then going to set my altitude bug. I set it up to 3,000 feet. That's the top altitude on the chart. So that's what I'm going to climb to initially, and we'll get higher altitude later. This is a great time for us to press the go around button. Now, pressing the go around button automatically turns my flight director on. Notice the hollow command bar, so the servos are not engaged, but we're set to wings level and a go around pitch attitude, roughly 7 degrees. And of course, we're going to verify. We see go around laterally, go around vertically, and I see ALTS in white. That's our altitude target select. That means I'm going to level out automatically at my selected altitude here of 3,000. So we get the power, we take off, flaps up, gear up, run through our normal checklists. Above 800 feet, this is per the flight manual supplement, and above your minimum autopilot engagement speed, we can turn the autopilot on. Press the AP button, and now we're still following that same thing, that same guidance. Wings level and go around pitch attitude. From here, I'm still climbing straight out, is when I'm going to turn and select heading mode on. So before we do that, we've already verified that our heading bug is still what we want. So I select heading mode. I can then select IAS, or indicated airspeed mode, and then I'm going to use the up and down wheel to set the speed I want to climb at if I need to fine tune it at all. Of course, once we're done, we're going to verify. So we're in green heading mode, following the heading bug. Autopilot and yaw damper are active. We're in an indicated airspeed climb of 100 knots with ALTS armed, altitude target select. That's going to level me out at 3,000. Next instruction from ATCs, turn right heading 120, join the Elvis departure. So easy enough for us there. I'm going to set the heading bug to 120, and that's what we're seeing on our PFD. Now, I don't need to reselect heading mode because I'm already actively in heading mode. That's what's green. So we don't necessarily need to re-engage anything there. I am going to go into my navigator and I'm going to verify that I have the correct leg active in the flight plan. In this case, from the Memphis VOR to the E-Tree waypoint. I see that's active. That's what we want to intercept. And we can arm nav mode. So I press nav and I see a white GPS. Typically, if your CDI is more than half scale deflection, when you select nav, it is going to arm that mode. So it's going to wait for you to intercept. Once you get a little bit closer, typically within half scale deflection, then that lateral mode, that nav mode will become active. So we're going to verify headings active. We're waiting to intercept GPS guidance. Autopilot and yaw damper are active. Indicated airspeed climb of 100 knots. Altitude select armed, waiting for us to level out at 3,000. This is a great spot for us to be in. And you can see CDI is inside of half scale deflection. GPS will then become active. Heading mode will drop off automatically. Now, half scale is a good reference point. Depending on the intercept angle, you may see an intercept earlier. You may wait a little bit closer to transition to that nav mode. It's variable, but the half scale is a pretty good reference point. All right, so we're now following GPS guidance. ATC finally lets us continue our climb. They tell us climb and maintain 15,000. So we're always going to start with a climb or descent with the altitude selector. So I'm going to roll my altitude selector to 15,000 feet. I'm then going to select indicated airspeed on my mode controller, and then I'm going to use the up and down wheel on the controller to set the climb speed that I want to climb out at. In this case, we'll do a cruise climb of 110 knots. Then of course, we're gonna verify everything once again. So we're still following GPS, autopilot yaw damper active, indicated airspeed 110 knots, altitude select armed, gonna level us out at 15,000. Once we get to our selected altitude, then you'll see our indicated airspeed mode will drop off automatically. It transitions to an altitude hold mode of 15,000 feet. So good things to monitor as we're leveling off and we get into cruise flight. Now, while we're in cruise flight, there's not a whole lot going on there necessarily automation-wise, but we still want to look up and verify. Everything we're seeing up on our AFCS status is still there. I still know what the autopilot's doing. Good item to keep with your normal instrument scan. So continuing on with the flight, we're getting a little bit closer to Atlanta. ATC comes back, tells us to cross Sweetie at 5,000. So running VNAV, step one is to program the descent. So I go into my GTN and I can locate the Sweetie intersection and I'm going to type in 5,000 feet in the altitude constraint field. That's step one. Step two is to set my altitude selector to the lowest assigned altitude. In this case, I want to set it down to 5,000 feet. That's what I've been assigned, that's what I've been given. Step three is to arm VNAV. So we arm VNAV, and at that point we can verify. So I see VPath on the 605, I see VPath on my vertical mode selections armed. We're waiting to get to our top of descent before it starts down. 1 minute prior to top of descent, you're going to see your VDI, your vertical deviation indicator. You're going to see a vertical speed target appear. Typically a little bit before, you'll show the next VNAV altitude the system's going to work off of, but they're all coming from the navigator, all coming from the GTN. And then once that magenta V centers, VPath becomes active, and now we're going to start following that VNAV descent, that program path all the way down to 5,000, and that's where it's going to level us out at. So while we're in our descent, ATC comes back. They say, hey, after crossing the Sweetie transit or Sweetie fix, proceed direct to CAVEB for the RNAV Yankee 08. So we have a little bit of work to do there. So we're going to go into our GTN. We're going to load the RNAV 8 Yankee, and that is a GPS approach. We're expecting LPV minimums. Great things to look at there. But they also gave us some additional guidance. After crossing Sweetie, proceed direct. So we need to do a little bit of flight plan modification. In fact, I'm going to delete Lacey, and I'm going to delete the vector leg. So from a flight plan perspective, we're going to go to Sweetie, and then we're going to proceed direct CAVEB. Since Garmin runs a linear flight plan, as soon as I cross Sweetie, it's going to immediately take me to the initial approach fix. From a navigator point of view, I don't need to activate the approach. It's going to automatically activate for me. And I'm looking at our multifunction display. I can see that. We're just about to cross Sweetie, and then I can see the white line taking me direct to CAVEB, and it's going to continue all along its route of flight. So now that we've leveled out at 5,000, ATC is going to then give us an altitude to descend down to. They say descend and maintain 3,000. So first off, we're going to start off with our altitude selector. Just like we did in the climb, we're going to start off by selecting 3,000. Then I'm going to select vertical speed. Now, I like using indicated airspeed in the climb. I like using vertical speed in my descents. That's what I teach most of the guys I go fly with. So I'm going to select vertical speed, and notice how when I select VS, it goes to 0 because that's what I'm doing right now. I'm not climbing, I'm not descending, I'm in level flight. So I will then need to use the up and down wheel to set the descent rate that I want. In this case, I'm going to descend down at 500 feet per minute. So I use that wheel it down. I see the arrow pointing down 500 feet. I can see that on my VSI, see the same thing on the 605. All that guidance, we're able to cross-check all of that. And of course, we verify. So vertical speed's active, ALTS is armed, so we know we're gonna level out at our selected altitude. Coming in a little bit closer, they tell us cross CAVEB at or above 3,000. You're cleared for the RNAV Yankee 08. Industry standard on this is when ATC clears you for the approach, arm approach mode. This works for ILS approaches, this works for GPS-based approaches. It's a consistency thing. So when ATC clears you and prior to glide path or glide slope intercept, arm approach mode. So we hit the APR button and I'm going to verify that I see glide path arm. That's the white GP. I'm also going to verify, or a great time to verify, we're on the right CDI source. So I'm on GPS guidance. Everything is in good shape here. And of course, once we get a little closer, we're still always going to verify what are active in our mode. So we're still actively following GPS lateral guidance. We're at altitude hold, and we're waiting for glide path intercept. This is also a great time to go ahead and set our missed approach altitude. I can change the altitude selector without fear of the aircraft climbing or descending, because from the autopilot side, it's being told to maintain 3,000. So it will. And when we intercept the glide path, we see the magenta diamond centered, GPS and GP are active. That's going to take us all the way down to the runway. This is also glide path mode is the only mode that will disregard the altitude selector. So if you did have it set at a lower altitude, glide path doesn't care. It's going to keep on descending through. Now the AFMS does call out below 200 feet AGL on approach work. The autopilot, he needs to be engaged. I go a little bit further with that and say, upon reaching decision altitude, you have two options. You can either disengage the autopilot and land the aircraft, or press the go around button and start into your missed approach. I would also encourage below minimum descent altitude, if you are going to go and descend below MDA, disengage the autopilot and hand fly at that point as well. Well, let's say in this scenario, we didn't see the runway. We didn't have our clouds, we didn't have our visibility, we need to go missed. Well, this is an easy one to do for us. We're just going to start by pressing the go around button. Just like on takeoff, we see go around laterally, go around vertically. I see the flight director set up at our 7-degree pitch attitude, and it's going to then sequence into the missed approach for us. At this point, power up, clean up, flaps up, gear up, everything, run checklist as appropriate. And also another great time to double check that we have the proper missed approach altitude. Now at this point, depending on your clearance, if you're told to fly the published missed, we would go back into nav mode, and that would follow the rest of that missed approach guidance, including heading legs, altitude legs, all that. It'll fly all that for us there, assuming we got the GTN interfaced in. And if we were given a heading, we would go into heading mode. So depends on the clearance, depends on what mode you'll go into. I'm also at this point going to change back into indicated airspeed, especially if it's that prolonged climb or if engine cooling is a concern. Go to indicated airspeed, set your climb rate, continue on out, and now it's just like we saw off the departure side. The benefit here, once we're in nav mode, if we are following the published missed, it's just going to take us all the way to our missed approach hold. I can see the course reversal, I can see the hold, the autopilot, we're leaving it in nav mode. I don't have to make any other selections. I don't need GPS roll steering. I don't need to worry about any of that. Simply placing this in nav mode will do this. All right, and that's going to take us up fairly close to the end of our scenario. Our primary text references for this is our G500 Pilot's Guide or TXI Guide. If you're running GI 275, all that, make sure you're reading through those. We also would look at the GFC 600 Pilot's Guide, as well as what I highly encourage you to read is the GFC 600 AFMS for your aircraft, flight manual supplement. This will vary based on your airframe. Of course, if you want to see if your aircraft is currently supported under our approved model list, go to garmin.com/GFC600. It's going to tell you what's currently approved, what's currently going through certification, as well as what's going to be planned within the next 12 months. If you don't see your aircraft on there, then there's a link to request your aircraft to be added, as well as a link if you'd be willing to loan your aircraft to be used in that certification. That's a never ending and evolving list. So take a look at that periodically and go from there. Of course, this is a little snippet of what we normally do with our instructor-led training. In fact, our instructor or GTN and flight display course, we do cover a little bit with the autopilots. Our kiosks do have this equipment in them, so you can get some hands-on experience with our in-person training. We do offer a number of different e-learning courses, instructor-led, both in-person and virtual, as well as the ability to create a custom course if one of those scheduled classes doesn't work out there. Also highly recommend taking a look at all the different e-learning courses and training courses that Sporty's has to offer. I've run through a number of their courses, and they also make a phenomenal product. So very highly encourage you to check out what they have as well. But as I said, that is going to take us up to the end of the day. If you do have more questions, feel free to email those over here to aviationtraining.webinar@garmin.com. We'll be more than glad to answer those questions. But that is all I have for you today. So with that said, I'm going to hand everything back over to Eric.
Thanks a lot, Matt. A lot of great information, and thank you for pointing us to a lot of great resources that we can get to for some additional information, including that email address, of course, that Matt provided, aviationtraining.webinar@garmin.com. Just once again, give us about a day and we'll have the fully recorded presentation up on the Sporty's webinar archives. And we certainly hope that when you are there, you'll take a look at the upcoming schedule. And hopefully there are some topics there that pique your interest, and feel free to register. We'd love to have you back. With that, we really appreciate you joining us today. And on behalf of Garmin Aviation Training and Sporty's, we'll bid you a good afternoon and safe flying. Thanks for joining us.